Hi folks, we're going to take a look at page 384, number 3D. So they want us to simplify this expression and state any restrictions. Okay, so I see logarithms that are being added together. So that's looking like a good use of the first logarithm rule. But this is where you have to be careful, because let's take a look at what the first logarithm law says. Okay, it says log base a of x plus log base a of y is equal to log base a of x times y. Okay, this is the law. Okay, this is the only thing we've established. So one thing I notice here is I don't see any coefficients in front of these logarithms. So if I see a coefficient of 2, I cannot use this property because it doesn't follow the exact setup for the law. Okay, so that's something to keep in mind. Just because you see a sum of logarithms, as soon as there's something else that's different here, in this case here having a coefficient in front, you can't apply the law yet. Okay, however, you hopefully realize that there's another law that does deal with a coefficient. Okay, because if I've got y times log base a of x, that's equivalent to log base a of x to the exponent of y. Okay, but what happens when I bring this up, if I use the reverse ski-slope rule, is that all of a sudden I'm going to be left with 2 logarithms, no coefficient. I'll be able to apply that first logarithm law. So the first step here is actually to apply the ski-slope rule both on the first and the last logarithmic expression. Okay, so this can be rewritten as log of u squared. Now, by the way, another reason why we can use these properties, at least when we get to the first law of logarithms, is the fact that they all have the same base. So remember, it's not that there is no base, it's that we assume it's log base 10 when we don't write anything. Okay, not much to do with the second one here. Okay, but we can simplify this here. This, I can use the ski-slope rule going upwards, so we have log of w to the 1/2. Okay, and now what we have is we have 3 individual logarithms that are being added together. So now we can apply the first law. Now, you could do this all in one shot, but I'll just do it in a couple of steps here since it's the first one I'm doing. So I'm going to take my time here, and I'm going to start with these 2 expressions. All right, and I see that the sum of 2 logarithms is equal to the logarithm of the product. So this can be written as log of u squared v. Okay, plus we have the second one, log of, and I'll write this as a square root. Okay, the more common form. And so now I can apply the first logarithm law a second time to these 2 logarithms with the same base. So this can be simplified into one expression, log of u squared v times the second one, which is the square root of w. Okay, and this is about as far as I can go. Now, let's talk about the restrictions here. And this is where you have to be careful. So first of all, logarithms are only defined for positive numbers. Okay, when you think about that, any logarithm function, regardless of the base, okay, either looks like this or it looks like that. Okay, if base is greater than 1, base is between 0 and 1, we see that the domain of these functions is always the values greater than 0. Okay, so logarithms are not defined for 0 or negative inputs. Now this is why you have to be careful, because you know, when I think about u, I think, oh, it's being squared. So if I'm only looking at the final expression, I might think, well, other than 0, I can put any u because it's being squared, so it's going to become positive. You know, and then here, well, this square root of w, I might have to eliminate certain values because of the square root. But remember, you always have to go back to the original expression. And we go back to the original expression, we don't have log of u squared, we have log of u. So u has to be greater than 0, v has to be greater than 0, and w has to be greater than 0. So the restrictions here are u greater than 0, v greater than 0, and w greater than 0. Now, this last restriction also takes care of the fact that we have a square root here. Okay, because you can't actually take the square root of a negative number. We don't have to worry about that here because w has to be greater than 0 anyways. Okay, so just to recap, number one, when you're using a logarithm law, you have to have the exact scenario. It's the sum of two logarithms with the same base. Okay, there can't be any coefficients. There can't, they can't be squared. Okay, it has to be exactly this scenario here. So we had to first apply to the first and third the ski-slope rule, and then from there we had valid inputs for our first logarithm law. Okay, that's it for this one.